On number 17 and 18, we don't have right prisms here. They're what we call oblique solids. So we're going to be using Cavaliere's principle in order to find the volume of these objects. So remember, Cavaliere's principle just simply says if you take a right solid and just push it over to the side, as long as the height has stayed the same and all your cross-sectional areas are the same, your volume has not changed. And so when we're finding the volume of this prism here, we look at all the sides appear to be rectangles, except, these are parallelograms, but we have a rectangular prism that has been pushed over to the side. So it's like that stack of books or stack of index cards that we visualized in class. They've just been slid off to the side. So it's still going to be found just like the volume of a rectangular prism, which is length times width times height. The height is not this slanted part right here. That's called the slant height. You still want the perpendicular height when you're finding the volume. And so that's why this little segment with 3 millimeters has been given. This is not part of our solid. This is just showing us the height of the solid. So when we're looking at length times width times height, typically the longer length is called the length, and then the shorter one is our width, and then our perpendicular height was given as 3 millimeters. So we're just multiplying 6 times 4 times 3 to find our volume of 72, and since it's volume, it's going to be millimeters cubed.